Hello, folks. My name is Beth Wright, and I am providing you the podcast for the Immunity Unit in NRS 211. We're going to talk about the anatomy and physiology of this system because I think that is crucial for you to understand and apply that to the different exemplars that we're going to be studying in this unit. And I feel like this unit or this system is super complex, but it's also fascinating. So we're going to describe some basic principles of the immune system. And let's start off with the lymphoid system. So that's a big part of the immune system because we have several different parts of that system that tie into this. And I wanted to mention that you have a couple of things to follow along with this podcast. You have the notes for this PowerPoint, but you also have an Excel document that I've posted titled The Immune System Simplified. And so to follow along, you'll need both of those documents to be able to apply it to the discussion that we're having. Okay, so back to the lymphoid system. So we have lymphoid tissue that's all throughout the body. And of course, we have the spleen that is a big part, an organ of the lymphoid system. And that is acting like, that organ is acting like a filter. It's where old and injured red blood cells are destroyed. And also, there's a high concentration of lymphocytes in the spleen. Then, of course, we have the lymph nodes, which are connected by lymph channels and capillaries that are all throughout the body, and they help remove material from the lymph system before it enters the bloodstream, and it also serves as a center for the immune cells to live, grow, develop. And so really important part there. Think about lymph nodes. I know you've studied some of that in your anatomy and physiology classes. And just think about that. We have that in our throat, like our tonsils. And, think about someone who's, has a sore throat. A lot of times those lymph nodes swell and, are tender. That inflammatory response kicks in. Also think about the individual who have had to have the lymph nodes removed, such as breast cancers, and they have to have lymph nodes many times removed. So those folks are, immunocompromised with that aspect of it. Also, I want you to think about the inflammatory response. And, this ties in really nice with the immune system because it is a big part of the immune system. And the inflammatory concept is actually one of the next units or modules that we'll be going into, but you all have had the basics of the inflammatory response and know that. So I think it ties in really nice with the immune system and where we're having it now laid out in the curriculum. All right, so now I'd like for you to turn to your Excel document, and that is titled Immune System Simplified. And so we have a left side of the page where we're talking about one type of immune response, and the right side of the page where we're talking about another immune response. And so let's start into the left side first. So we'll talk about natural immunity, and it's also known as the native or at birth or innate or non-specific. So you may see all of these different terminologies used from time to time when we're talking about natural immunity. And so a first line of defense is the natural immunity when we're exposed to an antigen. An antigen, just understanding what that is, that can be, you know, something that's introduced into the body like bacteria, toxins, things like that. It can also be the body itself thinking that it is an antigen. So just understanding that in simple terms is important. There's two stages. We have an immediate response, which is, occurring within a quick amount of time, and then we have a delayed response. Then we have the development of cytokines or cytokines. Sometimes you may hear it referred to this. Now, I love to think about the cytokines, and I'm going to use that terminology for it because I love the ending of this word, kins, okay? So, in Southwest Virginia or Upper East Tennessee, Appalachia talk, we refer to our family members as kinfolk, right? So think about cytokines as our kinfolk. Cytokines come to the rescue just like our kinfolk do if we're having some kind of trouble or distressed about something. Our kinfolk come to the rescue. So that's a good way to think about cytokines. And also other systems and substances come to help promote that whole immune response that occurs when we're exposed to an antigen. The inflammatory response kicks in, and with that we have chemical mediators that come to the rescue. We also have physical barriers that help with the immune response, and that is our skin. Our skin, that's the largest organ in the body or of the body. Mucous membrane, the cilia of the respiratory tract, coughing, sneezing, all of these things are considered physical barriers that help us with that immune and inflammatory response. And then chemical barriers are things like mucus and acid in the stomach, certain enzymes in the tears and saliva and sweat. All of those things help with that immune response and also that inflammatory response. We also have our leukocytes, are our white blood cells, WBCs, that come to the rescue with this side of the immune response. And so let's break down the WBCs there. We have agranulocytes and we have granulocytes. And basically what that's meaning is that the granulocytes have granules in them and the agranulocytes do not have granules in them. So let's talk about the granulocytes first. We have neutrophils, eosinophils, and basophils. The eosinophils are the neutrophils are the first one to arrive with the inflammatory response. Our eosinophils and basophils, they increase with any kind of allergic response or stress, and this causes a release of cell mediators such as histamine, bradykines, prostaglandins. Our agranulocytes are our monocytes and our lymphocytes. And so our monocytes are your macrophages and your phagocytic cells that work with the inflammatory response. Our lymphocytes are huge with the immune response, and this includes both the B cells and the T cells, which we'll talk about in a minute. Now look on down your page there, and I have in the middle of the page it says CBC with differential. And so what that is your complete blood count. Now when we get a CBC, complete blood count, you can get it with differential or without differential. A CBC without differential is just going to give things like red blood cells, white blood cells, hemoglobin, hematocrit, and some other tests that talks about the corpuscles, and the size of them, the volume of them, things like that. When you see a CBC with differential, that's where you see the white blood cells broken down to the micro white blood cells, if you will. And that's where you get these values of the neutrophils, the eosinophils, basophils, lymphocytes, and the monocytes. And I have those values there for you and what each of those indicate. And so next time you're in clinicals, take a look at that. Look at that CBC. Most of the time you do see the CBC with a differential, and check those out and see where your patients are and study those labs so you can get used to taking a look at those. Now let's go to the right side of the page and talk about the acquired or adaptive immune response. And this is results as after we have exposure to an antigen. And as you know, immunizations are a type of antigen that's given in the body, uh, or antigen can be an illness, or as I told you, antigens can be even the self, thinking that, that's it's, being attacked by our own body, or the autoimmune type of things. So the acquired immune system is, two different types there. We have the active type, where it's the body's own defense, and then we have the passive type, where passing immunity is from an outside source, such as a mother to the newborn, uh, immunizations, or IV immunoglobulins. That's a mouthful, isn't it? All right, so there's three ways, excuse me, that the acquired immune response happens. We have a phagocytic immune part, where the white blood cells, the granulocytes, and the macrocytes go to work and begin helping with that immune response. And then we have the humoral uh, aspect of it, which is involving the B cells from the bone marrow. So think about B cells, bone marrow, and that's where we have the manufacturing of anti-B bodies. Antibodies, okay? So B cells, bone marrow, antibodies are the humoral type of response. And then we have the cellular immune response, which is also referred to as cell mediated. And this involves our T cells, which comes from the thymus. So T for thymus. So there's four stages, and it's, I think, magnificent the way the body works, and just fascinates me all the time. And so the four stages involve recognition. So the lymphocytes and the lymph nodes are in constant guard, looking out for these antigens, and it recognizes the antigen. And then we have the proliferation stage that occurs, and that's where the lymphocytes with the antigen travels to those lymph nodes and tells the B cells and T cells to get busy, get to work here. The B cells release antibodies, and the T cells release killer T cells. Then we have the response stage. The B cell humoral response is where antibodies start going to work, and the cell-mediated T cells start going to work. And then we have the effector stage, and that's where our B and or our T cells reach the antigen, causing some type of effect. All right, so let's dive a little deeper into the humoral immune response and the cellular mediated response. So let's take the humoral response first. So this is where we have the macrophages and plus the B cells and the T cells. But let's focus on the B cells. So the B cells come from the bone marrow, and they produce antibodies, right? Now, antibodies are also known as immunoglobulins. They work by agglutination, which is the clumping together, and opsonization, which is where it coats the antigen with a sticky substance. And causes the inflammatory response to kick in and jumpstart other parts of that immune system. So our immunoglobulins and antibodies, there's 5 of them. It's the IgG, and that's your most abundant source of antibodies. The IgA protects at the entrance into the body, like in the tears or saliva, in the GI tract or the respiratory, and in the blood. The IgG, this comes to play when there's some kind of an allergic response or parasites. The IgD is in the cell membrane and B lymphocytes. And the IgM is the first to react, and it's the largest one. Think of M for mega. Now, we also have complements, which are proteins that help complement the action of the antibodies. And there's 3 functions of the complements. and it helps defend the body against infections. It also complements help bridge the natural immune response and acquired or adaptive immune response, and also it helps dispose of the immune complexes and waste from inflammation. All right, now let's go to the cellular mediated T response. So we've got several types of T cells. We have the effector Ts, and this includes the helper Ts and the cytotoxic Ts. The helper Ts are your CD4. The cytotoxic T cells are your CD8. And you'll see this especially when we talk about HIV and AIDS. These are going to be important to monitor. The helper Ts recognize antigens and help stimulate that response. They help secrete those cytokines. Here comes our kinfolks to help that activate the antibodies and attack the antigens. Also, cytotoxic T cells, NK natural killer cells, and the macrophages. Examples of cytokines include interleukins, interferons, tumor necrosing factors, chemokines, granulocyte monocyte colony stimulating factors, granulocyte stimulating factors, and monocytes. Now, you will see these because one fascinating part in medicine and treatment with the immune response is that they can reproduce the cytokines to help combat the antigens and improve the immunity of and the immune response of certain diseases. And so you'll see these actual drugs being given, interleukins, interferons, tumor necrosing factors. And so these are referred to as biological response modifiers. And I think that's one thing with the immune system is we're going to see continuous growth in that field where, they're developing new drugs to be able to combat different diseases. Now, our cytotoxic T cells or our killer cells are CD8, and they attack antigens by altering cell membranes, and it causes cell lysis and releases the cytolytic enzymes and cytokines. Now, we also, going on further to your right, we have the suppressor Ts, and that helps decrease the B cell production because there's times when we want to turn that off. And we have the memory T cells, and these are the ones that help recognize antigens from the past so that the body responds when it's exposed to that antigen in the future. We have null lymphocytes as well, and these are non-T and non-B cells that destroy antigens already coated with antibodies. So, hopefully that's been a immune system simplified discussion for you. So you have some pictures in your notes of the components of the immune system, and just again honing in, driving home the importance of that lymph node or the lymphatic system with the tonsils, the thymus, the bone marrow, the spleen, and of course our white blood cells that are important as well. So we got to think about our immune system as this. It's all the time on guard, ready to protect, ready to go to war against pathogens, against antigens in our body. So I want you to just think about that as our immune system as that, and why it's important that we keep our immune system healthy. It protects the body from potentially harmful substances. That inflammatory response is a part of that, and it occurs when tissues are injured by bacteria or any kind of other cause. And so the immune response kicks in and So when you look at this picture, you see those nice looking planes up above there, or jets. And so just thinking about, those are all in harmony there, flying together, looking awesome there, right? And our body has to have two things happen for the immune system to respond. First, the body's got to recognize that it's being threatened. And then second, it has to recognize that the threat and the response before the cells are destroyed. So it has to recognize that. And the immune system, it's extremely smart where, it says like, hey, I know you. I know you. You're trouble antigen. You're trouble. And so it's critical that it can tell that and that it doesn't, think of the body itself attacking it. And that is what happens in the autoimmune disorders. So you might be thinking if our immune system is working, then why do viruses, bacteria, and other foreign agents make us sick? Well, not only is our body and our cells all brilliantly structured to be able to go to work against antigens, but also those bacteria and viruses, allergens, all of those are smart viruses and smart cells as well. They try to mimic our own cells to avoid being destructed. And so we're going to say they are flying under the radar. So you might think of it as a wolf in sheep's clothing. That's what viruses, bacteria do. They are smart. You hear about antibiotics, and folks becoming resistant with certain infections when they've taken a round of penicillin, let's say. And it's because those viruses and bacteria have, like learned the whole penicillin structure and they, you know, are no longer like affected by it. So when we talk about HIV, you'll see that those viruses are extremely, I'm going to use the term smart, and they can replicate and replicate and replicate, and they're resistant to different types of treatment because they're smart too. So, when we have a suppression of the immune system, we call that immunosuppression, or we also, you'll hear the term immunocompromise. And this is when the immune system is weak or injured and the person gets sick often. And there's several things that can cause that, different diseases, like cancers. You've already studied that. So cancers definitely, the disease itself is can cause or does cause immunosuppression, but also the treatment, radiation, chemotherapy, all of that is immunosuppression or immunosuppressive, and it not only affects the cancer when we give cancer treatment. It does affect that, but it also affects all of our cells. So the person becomes immunosuppressed. HIV and AIDS, certainly uh, those patients are immunosuppressed because this definitely impacts the immune system. Also, the treatment for it are, antivirals. So it too, anybody on antivirals, they are immunosuppressed because it's suppressing the immune system. Organ donation clients, they have to take immunosuppressive drugs because the organs are thought of as an antigen. It's, when they receive an organ from a recipient, they, the chance of the body saying, hey, that's an antigen, and it starts attacking that organ is extremely high. So the person has to take immunosuppressants, and it makes them immunosuppressive. Then the other flip side of the immune response is an exaggerated immune response. And this is when our immune system is in overdrive, like it is working overtime. And so an example of that is a hypersensitivity reaction, or we also call that allergic reaction. And the severe form of that is anaphylaxis. The other exaggerated immune response is the autoimmune, and that's where the body starts attacking itself. And an example of that is a systemic lupus erythematosus, okay, also known as SLE. So I hope that this has been helpful, and that's all, folks.